Good morning, students. So I am Saravanan. So we are seeing about medical electronics.
Battery.
So let's proceed. So in this, before going into the session, let's discuss what we have seen so far. So we started with introduction to the subject, why medical electronics and where medical electronics is applied. Then we went on for biopotential, origin of biopotential, how voltage difference happens inside the body. Then we got into how these electronic means ionic current is converted into electronic current. Then we saw how this little microvolt is being amplified and converted into voltage range. So there are so many amplifiers. Then we saw about different biomedical recorders. So these are equipments that will record the electrical activity associated with the heart. So which is called as electrocardiogram. Then electrical activity associated with the brain is electroencephalogram. Electrical activity associated with the muscle is electromyogram. So then we went into second unit, which is pacemakers. So pacemakers, why pacemaker is necessary, what is a pacemaker and what are its uses, what are its types, we have seen in detail. So there are two types, one is external pacemaker and internal pacemaker, and there are subdivisions also. So in today's class we will get into another half assisting device which is called as defibrillator, cardiac defibrillator. There are two words here. So one is cardiac and the other one is defibrillator. So cardiac is familiar as of now. So electrocardiogram. So cardiac means it's a biological term which means heart, right? So defibrillator is a new word now. So before going to defibrillation, we should understand what is fibrillation, right? So it's a medical term, but the concept is very simple. I'll explain to you. Right? So this, see, the atrium and ventricles need to function in a synchronized way. So this is normal. See, both atriums need to function together and then ventricle. Whereas in abnormal conditions, see, one atrium and the other atrium functions asynchronous. So due to which, see, this atrium has to function first and then ventricle. Whereas in certain conditions, when the sinoatrial node fails or partially fails, this happens. So when this happens, I think you can understand. But what happens to the blood flow? The heart will not pump, will start to do something like shivering. So I have shown it to you here. You can see that this is the normal activity. So from atrium it should come to ventricles and from there it needs to go. Whereas here you can see due to asynchronous pumping of the heart, so we can see that the blood is not actually pumping out, it is circulating inside the heart. So obviously this results in fatal. Fatal means death. It's a medical term, right? So this is fibrillation, right? So this is a normal condition. To do this, we need not do anything extra. If you just provide a shock to this heart, sometimes the heart activity might reset. It means it will not always go result in a success ratio, but this is somewhat trying our best chances. So this we even do it comes with some equipment. When there is a loose connection and something happens, you use to give a shock by just beating it or something like that. Similarly, what we tend to do is we tend to do the same thing but through electrical one. So that is what defibrillation is. Fibrillation is malfunctioning of the heart. Defibrillation means resetting the malfunctioning of the heart to normal functionality. So that is why we call it as defibrillator. Fibrillation is quivering. Defibrillator means stopping this quivering of heart. So that is defibrillator. You can see this you would have seen it in movies. Right? So, hero or heroine will be suffering, will be at the verge of death, then the doctor will come, do this. So, right from Mission Impossible movie till Shivaji movie, so this happens. So, you not have understood. So, these two things is nothing but the electrodes. So, when they tend to place it for a momentary period, they will try to give a high voltage shock. So, you can see that's what I have written it. A shock is given to the heart muscles, can reactivate heart, the pumping process. So this is a fair means of trying. It will not always result in 100% success ratio, but this is what actually happens. So today we will see one of other one is DC defibrillator. So AC and DC, you know it, right? AC means alternate current is given in these electrodes to provide the shock. DC means direct current is given to the body through the electrodes to give a shock. So we'll see one way. So in this session we'll see only AC defibrillator. So this is how the AC defibrillator actually looks like. You have a transformer, right? So basically most of the time this will be an auto transformer. So according to the level of voltage need to be given. So we'll try to arrange. So from the secondary of the transformer, we'll try to give it to the electrodes. You saw two electrodes, right? So that is why there are 4 terminals here. So this is one set and this is another set. So in between there is a switch, right? So this switch is a timing circuit. So this is not a manual switch. This is a transistorized switch. So for a simple operation, this is simply told like a manual switch, but it is not so. So the switch will be closed for 0.5 to 1 second. So just 1 second it will be there. So that's how it is. So basically, there are 2 things to remember. So this defibrillation is nothing but it's a means of giving counter shock to the heart. Counter means an opposite action, counteract. So something like that. So you tend to give a counteract to the heart activity. So this is basically given from 0.25 to 1 second at the maximum, not more than 1 second. This is because when you try to give more than 1 second, there are 2 things which can happen. So one is this voltage, this high voltage itself will try to harm the patient and make him dead, or at least it will result in skin burn. So we are trying to keep a higher voltage to the skin surface. This is external defibrillator, right? So skin surface, so which will result in the skin burn. There is also internal defibrillator which we will see in the forthcoming classes. So this is the basic diagram. So here fuse is an optional one. This is how the AC defibrillator will look like. So this is what that person uses. So this is the electrodes. So this they will try to fix what voltage need to be given. So maximum 400 volt is allowed. So that's what they will give, and this is some other options. So here there will be a monitor which will indicate from where you are trying to keep it. So that's what. There are different models available based upon the manufacturers. So this is another one. So here the electrodes have a handle here. So this is Phillips made. It can be, but in basic functionalities, the screens, there is no off selectivity, and everything will be almost the same. The models will look different. So this is as far as AC defibrillators is concerned. So we have planned an industrial visit to Gen Hospital. So we'll try to see both DC defibrillator and AC defibrillators together. That's all for today. So any doubts or suggestions?
Okay. My suggestion is in a particular slide you mentioned the types of defibrillators, that is AC and DC.
Yes.
So here you can add. So AC means what is the voltage range ranges?
Okay.
For example, some 0 to
400 volts.
Or DC means
Yes.
better we can add to the balance.
Yes. Yes.
Is there any types available in the AC defibrillators?
Yes, sir. There are some types. We will see one by one the forthcoming classes. So first, my idea is to say what is AC defibrillator, then DC defibrillator, then go on to the types.
Okay, my suggestions are, so DC, right, actually this is functioning based on frequency or voltage?
Voltage 50 Hz. AC defibrillator works on fixed 50 Hz.
But in DC, if you select DC, how far whether DC power supply will not have frequency, right?
It is zero frequency.
Then,
So here frequency is not a matter. Only the potential is taken as a shock. Suddenly, so everything works in a micro and millivolt, right? So minus 90 millivolt to plus 30 millivolt. So suddenly you give it to 400 volt something, or 230 to 400 volt. So that undergoes a shock, and that can reset heart. This is only a possibility, not always.
And thematically, I want to convey a small point. If you go to this one, first slide, which is given the yes, this one, that art diagram you have, no 3D diagram. Next one. Yeah, of course.
Yes.
So if you given the fibrillation, which part you are given a good explanation, right? So actually you are giving in chest, right?
Yes.
That's 2 points. Obviously, That is the actual point what we are going for.
It happens in atrial region. So yeah, I can show that PQRS
Yeah, for
wave.
PQ. Based on the PQRS, we have to discuss.
Okay, sir. Okay, sir.
Thank you.
Okay, sir. Thank you.